everyone. In this video, I'm going to talk about C++ STL. Now, what does STL mean? That you all must be knowing. STL stands for Standard Template Library. Now, what is this, and what is the role of this library? So, STL basically provides some data structures and like data, and S here stands for structures, what I'm mentioning, and some functions. So, what both these do? Like a standard template library, that is your STL, provides two things, that is data structures, function, and the third component that it provides you iterator. What it provides you? It provides you iterator. Now, why we use STL? First of all, just to more throw some more light on this, like data structures. Now, what are the data structures that you must be knowing? Like if I write data structures as DS, so what are the different data structures that you must be knowing? You must be knowing about stack. At least you not if even if you don't know much about them, you still must be knowing their names. Like the next one is queues, and the next one is priority queue, and so on. Like the next are, if I just go on writing, the next will be vectors and your list, your DQs and all. So how do we do them? So these are your data structures, and the functions that we have for them are like push, pop. Now, what do these functions exactly mean? I will be telling you one by one. Front, top, two more of the common functions that we use. Swap, sort is another common function. You use it. Sort, it is like that. So this is your sorting. This is your swapping. There's that. The other function that you normally use, it's a function one line statement, that is size, like that. So these are the common functions that STL provides you to apply on the data structures, various data structures that I've mentioned in this particular page, like stack, queues, priority queue, and your DQ, your vector, your list, and lot of them. Like so, this is about what is basically STL. Now, STL has like quite some parts, what I mentioned here. So STL has got some algorithms. Now, algorithms are not like the typical ones that you study or you must be studying in data structures and algorithms. It is algorithms here. Just let me explain you. These are the containers. So these are what? These are the containers. The next part. Then comes your iterators. So like iterator, you will get to know when I will be going to show you in the VS Code. And first of all, let me talk about algorithms. So what are algorithms basically? Like STL, the parts that I've written, the components of STL, if I write here, components, if I write about components of STL, so STL has algorithm, STL has containers, and STL has iterators. So if I go about talking to you about algorithms, algorithm. So I think couple of pages back or frames back, whatever you call here, couple of frames back, I simply talked or I mentioned about like the number of functions that are here. So algorithms provide you basically a collection of functions, a collection of functions, a collection of functions that you can apply on these data structures. Or in other words, you can apply on containers. Like algorithms mean what? It provides you a collection. Algorithms are basically collection of functions that can be implemented on containers. Now, then the next question arises that what are containers? So, if I go on explaining you about containers, so containers are basically your data structures. Now, they all are not classified. So, what are containers? In basically, in one word sense, they are your data structures. Now, there are a number of types of data structures here. So in that way, the number of containers are also there, but all come under the heading of containers only. They are subdivided into that. So the first one is your sequence container. The first one is your sequence container. The second one is your container, container adapters. This is adapters. So I will mention it on the next page as well, not way. Like container adapters. This is your second. The third one that comes in the category of containers is associative container. What it is? It is associative container. So if I talk about containers, so containers are what? Basically, containers are your data structures, and in data structures, like containers are divided into three categories. The one is sequence, the other one is your container adapters, like the other one is your container adapters, and the last one, the third category is your associative container. Now, what type of data structures do each contain that you also must be knowing or that you must know? Like the first one is sequence container. What data structures it has? So sequence data structures has your vectors, your arrays, then comes the list, then comes your like DQ, this is. So this comes in your sequence container. The other like now we will come to container adapters. We will be coming to container adapters. So we'll be coming to container adapters. Now container adapters contain your priority queue, which I will be writing with PQ, your queue and stacks. These are the type of data structures that each type of container carries. Then comes your what you call associative containers. So associative containers contain your maps and sets. Associative containers contain your map, multi-map. Now, what are these structures and how are they differentiated? I will be telling you. Your multi-map set and in the same way multi-set. So, like what associative containers contain, type of data structures, they contain map, they contain multi-map, they contain multi-set, and they contain set. So, this was all about the type of theory that you should know about STL. Now, we should come to our first data structure that I will be explaining you about. That will be simply your vector. So I'll straight away jump into the VS Code and I have created here an C++ file that is stl.cpp to just run the type of different data structures and the functions that they provide. Now, as I have been using in my last videos, that I include the basic folder. So this folder actually has got all the kind of functions that you should include, the basic header file to include. Now, if you are using IOStream, then you have to include set also include. If you are using vector, then you have to include vector. So so that will make the code. Suppose if you are using multiple data structures, then you have to include a number of header files. So that will result into what? That will simply result into the length of code getting longer. So in order to avoid that, you should include this particular file that is bits stdc++.h. So now your basic using namespace std. So I think this much is clear. Then we will straight away write the main because since we are doing the demonstration here. So in main, what I will be writing, I will be writing vector. Now this is the syntax for the vector. Vector int v is equal to. We can straight away like declare a vector. We can create an empty vector and and then we can simply insert the elements. So both are okay. I will tell you in both the methods. So like if we are writing at 20, 30, 40, 50, 60, these are your elements. Like the elements of the vector are 20, 30, 40, 50, and 60. So if we do like, so now your vector in this way, if you are statistically initializing it, so in this way, your vector is simply created and it is of size what? It is of size 5 because it contains what? 5 elements. So if I write here, like why this is giving an error, I haven't included vector here. So if I write here cout v dot size, so what output it should give me? So it should give me basically output 5. We will check it as well. And now comes the concept I told you about another component of STL that is iterator. So how it comes into play. So while we have to print the vector, like if we have to print all the elements of a vector, so how we do that? We simply write this syntax for auto. Now, what does auto mean? Like if we write the basic for loop, we write it like for int I is equal to something, or if we have to initialize it with a float, then what we have to use for float f is equal to something kind or double d is equal to something we normally use while we write the for. But with the help of auto keyword, it automatically detects the type of value. Like what will be the data type of the variable depending upon the value. Auto keyword does that. So we write here like this. Now the I is what here? I is an iterator. Simply. Then we do it like this. This particular like colon. This stands for colon. And colon actually does what? If I write here V, then this sign means that for auto I on V. So I have to apply I on V, and simply the values here, I simply declare int. Now, if you didn't have to write, then you have to write like for int, I is equal to 1 or 0, less than size and all. So this is a small syntax. And then I have to simply write here C out. Then since we are iterating through on V, so we have to simply write like this. And this results into, if I do like, if I just simply write here ender to get each and every element in a single line, then I have to do what? So this is the basically the syntax to get the vector printed. Like I will write here prints every element in a single line. This is the function. Now, what if I just do this, like if I just go on explaining this, so I should run the code as well. So I'm going to run it and let's see what the output comes. So like what is the output comes? So see, now why 5 is coming here because I never applied here, I presume endel. So this will change the line. And if I run it again, so I think so I will be getting here. Yeah, I got it. So the elements of vector are printed, and over the first output line of output actually gives us the size of the vector, which is 5, as I told you. Now this is one way. Now suppose if I just create an empty vector here. So how we go about initializing it? So straight away we can't do here. So firstly, if the vector we have created an empty vector. So in order to get the elements in the vector, we have to use some functions here. So what we use here for int, so since we have to like we will simply actually if an empty vector has been created, like the syntax for an empty vector is simply like this. You have to write the vector keyword, then you have to mention the data type here, and then you have to simply mention the vector name, like what particular name you have to write. This vector V can be V1, it can be V, it can be W, it can be S, it can be anything. So that depends on you. And how to insert elements in vector. Here comes two functions like pushback and emplace back. Both are okay, but normally the efficiency of in place back is more. I will mention with both. Like if we do like this, v dot push back simply. If we write 20, then 20 would be inserted. This is the method. 20 would be inserted. And if we write v dot push back again, so what is the syntax? It will come as 30. If I suppose right, I will be writing the same syntax. And if I write push back dot 40, and not going much about that. So let me just simply do it. So I will be mentioning here 50 and I will be mentioning here 60. Now, if I run this code again, now this is the method I am just writing comments also that method to insert element in a or in an empty vector. What it is, if I just take this and just vector, and if I run this code again, you will find that this particular thing will do the same if I run the code. You can see there is nothing difference between the two. And suppose if I use in place back here, suppose if I use in place back, suppose I am writing here in place back. So I would write in here in place back in place back takes lesser time. This is the basic difference between in place back and push back here. So if you are thinking that the thing will change here, so simply it won't. It will it will still be the same. You can see. Can you see any difference between the last two outputs and this output? Obviously no. So this is the only difference. And when you do competitive programming and all, where time constraint is there, hopefully like in IDE you just have to keep one constraint in mind that your loop shouldn't run indefinite times. So you have to just keep that constraint in mind and use any of them like pushback or in place back. But if you are using like in a particular coding platform, then you have to use in place back. That is more advisable. So this is the syntax. And you can also take here an array and then you can just simply using a loop so that all this will be. Now here only 5 elements were there. But if you have to use 10 elements or 15 elements like that, then you can't simply go on writing pushback, pushback, pushback. So you can firstly initialize an array with all the elements and then using a for loop, you can simply insert the elements like this. Now, if I write like this, v dot pop back. The pop back element doesn't take a particular argument. So this is the particular thing in vector that you have to keep in mind that pop back doesn't take any element. Like pushback takes an element, that particular element which you have to insert, but pop back doesn't take any particular element. So pop back does what? It removes the last element of vector. So if you print the vector again, then you will find like if I just do this code again, if I do this code again, so what you will find that this output now will simply print till 50. The 60 won't come this time. And just simple as that, if you want to write the size of the vector as well. So if I just mention again size of vector, so you will find now what? You will simply find that the size now comes 4 because the last element will be deleted. So it removes the last element of the vector. So I will run the code again and you will find here simply like see. First, the size of the vector that we initialized, that was 5. Then first, initially the vector that was after being initialized, the vector printed like 20, 30, 40, 50, and then 60. Now, then I applied the pop operation. So pop operation does what? 20, 30, 40, 50. Size of the vector 4. So now 60 got removed. What? The 60, that particular element, the last element of the vector got removed. So this is about vector. And if you declare two vectors, then you can use simply functions like swap. If you want to change the content, suppose in another vector 10, 20, 30, 50, 90, like that elements were there and you want to exchange the contents of the two vectors, so that will happen. And for swap function, the size shouldn't be a constraint. Like you can't there is no constraint like that two vectors should be of the same size in order to change the content. If one vector is of size 3 and the other vector is of the size 5, then contents can be exchanged and one vector like vice versa. The number of elements in the particular vector, that will be its size simply. Now in this particular sequence, I push back to the elements in a particular order. That was ascending order. That is like the smallest element at the top and the largest element at the. Suppose if I reverse it, like simply I write it here, like let it be 20, and I just exchange here. I just change these two elements. This will become 40. This will become 30. So I just changed these two elements, and for now you have understood the pop operation. So I will simply delete it. I will simply do what? Or I will comment it out. No worries. I will simply do this. So Now the size of your vector has become like it has become 5 again, and the 60 element is there in the vector. So if I run the code, what I will be getting? I will be getting here 20, 40, 30, 50, 60. Now you see, unlike the previous time, the vector this time is not in an ascending order or in a descending order. So how we sort it particularly? So this I have done basically to give you a demonstration of sort. So sort v dot begin. Now v dot begin is basically an iterator which will point to the first element of the vector. That is from where you have to start. What does v dot begin do? V dot begin simply points out to the first index of the vector, comma, where you have to go, v dot end. And I would prefer that you should write here -1. Now v dot end actually points out to the last element index. Like v dot element points to the last at it is, remember, v dot end is an iterator. So iterator is actually points out to the address. So last address of the array or a vector. But v dot end -1 actually takes you to the particular index, like where you have to sort. Like if you write here, let me tell you in simple words, if I just go here and just tell you about v dot end, like v dot end is this, like simply. So v dot end actually takes you to the ending address. It takes you where? It takes you to the actually ending address of a vector of a of this of of vector. So if you do v dot n -1, you simply go to the last element of the vector. So this is the method. And then I will just simply do what? I will actually again write the code. So simply I will do here. I won't write the code again. I will simply let it like do like this. And I just simply do it like this. So I don't want the size again. So I will do what? I will simply comment it out. And then I will go like this. And why? Okay, I never put a semicolon here. So, okay, all good to go. And then again, I'm running the code. So let us see what we are getting here. So I think initially the size was 5, and then we got the elements printed in the way that we initialized them, and then 20, 30, 40, 50, 60. So I think it is an ascending order. So sort dot sort simply the sort function. Remember, sort function actually sorts the array, sorts the array, or sorry, here we are doing with vector. So sort the vector in ascending order. In what? Ascending order. So hopefully, like simply this vector would be clear. Just remember that sort actually sorts the vector. The sort function actually sorts the vector in ascending order. Now, what is the time complexity of sort? So the time complexity of the sort function, remember, it is simply, I am writing here, time complexity of sort function is O n log n. Your swap and size have big O of 1 complexity. Sort function has its time complexity big O of n log n. So it is clear. Swap has its simple time complexity like big O of 1. Your size function has its time complexity big O of n, sorry, big O of 1. Size function has its time complexity big O of 1. I'm writing it here, so it is not a confusion. Size function big O of 1 Swap function also takes big O of 1, no problem. And simple, it is like sort function takes O and log n. So I think that will do the job. So this was all about what you call vector. Now we will come to another data structure, that is your list. So as I told you initially that vector, your list, an array and DQ are comes in sequence containers. So these type of data structures come in sequence containers. Now, just like the vector, we should first know about the header, like how we declare a list. So we simply first write list, that is the type of data structure that we want. Then we write the data type of the data structure, and then we simply mention the list name. I will be using a list one, as simple as that. And then I will be writing here semicolon. Now, this is the way of writing one. Now here we use two kind of functions. I will be writing here list just like we had the pushback. Now pushback what means? That the elements were pushed, like one push, then other, then other, then other. Push means simply you are inserting. Here we have two kind of functions. We have pushback as well, we have push front as well. So any kind of function you use. Like if I write here push back and I insert here one, and let me take another list dot push front. So I'm writing here two. Then according to like you, what you would be saying that what will be the output of the list? If I just simply like write here for the iterator method of printing the vector and the list is just the same. I have to just write I, that is auto, what kind of data type we are using and on which data structure I have to apply. So that is your list one. And then I have to simply write what we used to write, C out. Then we have to write the iterator, and to print each and every element in a single line, I will be using endless. So I think this will be the factor. Now, according to you, if I ask you the output, what will be the output if I'm printing this list? So for that, to know that, I will be running the code. So let's see what comes the output. So output comes to 1. Now, there might be people who will be actually realizing it how it happened, and there is will be still some doubt. So how it actually happened? Like this is the difference of this function push back and push front. When you are using push back, particularly one, then if I had used push back again for two, then this two would have come after one. But I'm using push front, so this two is coming before one. So this is the case. If I would have used, like if I've used list dot push one, one, so one gets into the vector, sorry, in the list. And if I would have used list dot push back two, so two would have inserted after one in a very sequential manner. And then simply, if you have used again whatever kind of function, it would have been inserted like that. So now you would be thinking, now how would I insert the third element? So I will again write here list dot push. I will be using again push back 3. What will be the output of this? What will be the out of this according to, like, if I write here? So just before running the code, just understand this. You inserted the first element in the array or in the list, that is 1, using pushback. And then you used push front to insert the other element, the second element. So push front will simply take the element after the first element or in the before the first element. Push front does what? It places the element in the particular data structure before the previous element, not after the previous element. Simply, if just a very simple English analogy here, simply that the back actually takes the value after that particular and front will actually keep it before. So just that. So this output will come if we just 2, 1. And then I simply did what? I simply did here push back again. So Now your data structure has two elements. Two, one, list. You are now using push back to insert the third element. So how that particular, where will that three go? It has only two options. Either it can go above three, above two, or it can go below one in the data structure. So the answer to this is it will go 213 should be your output. So I'm going here, I'm running the code again. So you will be finding here 213 is your output. It's as simple as that. So this is all about your list. And again, you can do the same operations of sorting and because data structures remain the same here. The type of data structures remain the same. Iterator concept is same. Auto is same. And auto keyword basically does what it automatically detects the type of the iterator. Like whatever kind of value you are placing in the iterator. Like suppose if I place for I equal to 1, then auto will automatically detect the data type of the iterator that will be int, that is integer or double and all whatever it does. So this is the method. Now if you want to avoid pushback push front, then the other type of method is simply like this. You can use curly braces, and in curly braces you can write the elements that you want to put. Suppose I want to put 1, 2 and 3. Now the problem here is that if you want to get your data structure in this format, you can't achieve with that. If I just go on like printing it, then you will find that this will simply use the method of pushback, like 1, 2 and 3 will be your output. Simple. So I'm going to run the code again and okay, so where is the error? Let me do it. So that error, what we were getting, if we just run the code again, I just told you what you will get. You will simply get the output as your 1, 2, 3. Now, this particular type of declaration of a list will simply take into analogy that you are using the pushback function for all the three. If you want to achieve the particular data structure in this particular format, then you have to use pushback. And in order to, if you want to achieve this structure of like a different kind of a sequence for your list, then you don't have to like write push back push front like this. You have to simply take an array, you have to just declare it like this, and using the for loop you can simply push the elements inside the list. Again, for push and push front, all for all these data structures, like for the sequence data structures and container adapters, the time complexity for the push function and push function, that is the insertion part, is your big O of n. The time complexity for, again, I'm saying the time complexity for this particular data structure or for sequence containers and container adapters, the insertion time complexity would be simply big O of n. For sorting, again, it will, and for swapping it will be big O of 1. For size, you can also print the size of the particular list, that will actually come 3, that is equal to the elements of the list. And like it will, size will also have its time complexity big O of 1. So this is the type of a particular structure, that is list. Now we come to the next data structure, that is your stack. And arrays, I will come to DQ as well. And before that, I will try to give you an idea of stacks and queues, because you should be knowing about like what is exactly, first of all, your stacks, queues, then comes your DQ and all. So I will just simply format document. Now I'm going to tell you about stack. So as usual, what we are doing for the past two data structures, we'll be simply writing a stack. Stack defines here the type of data structure that you want to create. Then comes the data type of the structure, and then comes this data structure name that is subjective. Like you have to write, that doesn't come from the language. So that I will be writing again, and I'm doing stack one. So this is the type of particularly This is what your, I will be right mentioning here in comment. This is your header for stack data structure declaration. And
Moving on, the next thing that we will be having.
so the next part that comes here, like you declared a particular data structure. Now, just like the past two data structures, what was supposed to be done here in the particularly data structure declaration? Like, firstly, you write the mention the type of the data structure that you want to create. Then you mention the data type, like that particular vector will be of what data type, that particular list will be of what data type, or that particularly stack will be of what data type. And then you simply mention the name of the data structure, like how you will identify throughout your whole program, simply. And then comes your how to insert the element and how to delete the element. Simple. Well, like in the past in the list, I just forgot to tell you about, like there are two type of functions. If I just like comment this, and if I go on, like this is there. So for this was for basically to insert the element. In order to like delete the element, again we have two type of functions, that is your pop front and pop back. Simply, in order to have, like simple, it's as simple, it's just simply like that. You have, like if I write here list one dot pop, pop back it is. If I mention it, and again you don't have to pass a particular argument inside this parenthesis. List to pop back function doesn't take any argument. And then I just simply print the list again. I'm just trying to tell you about the pop back and pop front function. So I won't comment this out. Let me do this. I will take this and I will simply write it here. So I'm trying to print the list again, and I have deleted the pop back function. So my list is simply this. I will comment this out. Now I will just place it. Now I'm running the code. Like this is not there. This simply now it's good to go. So if I'm like popping back, I'm deleting the element. So 1, 2, 3, then it comes 1, 2. Like the element was deleted from the back. So from the back, the last element was 3. So 3 got deleted. And suppose if I had used pop front, so the element from the first, like the first element would have been deleted. Like front and back are just work according to the English meaning. It is not anything different. So the output will be 2 and 3. So you can see firstly the your list was printed, and then the after deleting the first element of the list, 2 and 3 got printed. So again, this particular function deletion will also have its big time complexity as big O of n. Just like and this is again for same for your sequence containers and container adapters. This is same again. I'm repeating. Insertion and deletion has its time complexity as big O of n, and this is same for sequence containers and container adapters. Hopefully by now you must be knowing what are they. So this was all about your list, and coming now, I will be going to explain you about your stack. So what is a stack? So this much I just told you, I think. Stack. Firstly, we mentioned the data type, then we mentioned, sorry, firstly we mentioned the type of data structure, then we mentioned its data type, and then we mentioned its name, that how you are going to identify it throughout your whole program. So how, moving on, how we go ahead. Now, in order to insert elements in an stack, or in order to delete the elements in a stack, how you do it. So if I just explain you something before we proceed, your stack follows, your stack follows. Now, please don't relate this to your the previous two data structures.
Remember that this particular data structure is from your container adapters. Those two structures were for your sequence containers. Your insertion and deletion time complexity will remain the same, but the rest of the properties of type of containers will change. So your stack follows. I hope this word you must be well known about. This is LIFO. LIFO structure it follows. Now, what is this LIFO? If it basically stands for last in, first out. Now, if I explain you like that, suppose this is your data structure and this is your first element, this is your second element, this is your third element, this is your fourth element. Now, I just mentioned it. This is your fourth, this is your third, this is your second, this is your first. Now, suppose if I have to take out particular element, then which element will get removed from this stack first? This particular element. And on which order it was inserted? It was inserted at the last. So what happened? The particular element which got inserted at the last removed was removed first if we have to remove it. So this is the particular concept of the stack. Now coming here, if and how we will be inserting the elements in stack, that is as similar to as push and pop. Now here it doesn't come any back or front. Like push back or front, there is no concept. There is simply the two functions are stack, that is front, sorry, that is push and pop. Push simply does what? It inserts the particular element inside your data structure, and pop actually removes it. And stack one dot push. I will simply be using very simple elements. Stack one dot push two, one dot push three, and stack one dot push four. Now this is it. Now there is a function like we used to iterate in case of vector and list. There is a function known as empty. Now empty function does what? Empty function simply does like this. Empty function will simply write stack your particular data structure and we will simply mention empty. Now this particular function simply does what? This is a Boolean function. It simply returns true or false. Its return type is Boolean. Like stack dot empty will simply return you true if your stack has no elements, and it will return you false if it has some elements. So we are doing here, if stack.empty output is true, and using the not operator, we are simply changing it to false, like stack. Then we'll simply doing what? We'll simply doing stack dot top. We'll simply doing what? Stack dot top. Now how we will be using it? You will be using like this. You will simply, I am again going to take it in end. And similarly, you will be popping the element as well if I do this. Or simply let me just show you. If I'm running it, what will be your output? Let's see. So I'm telling you now the reason why actually it got like it is running for indefinite times. The reason for this indefinite time running of this particular loop is that in the condition we have applied stack.empty, that this particular program should run till the time stack is not empty. So we are, if I'm not deleting elements from the particular stack, then at no point of time it will going to give the output stack.empty, that stack is actually empty. So how we actually do this? We'll simply stack your data structure dot. As I told you, we will be popping elements as well. So simply how we are going to do this? While we are just simply popping that particular element. Now pop does what? It actually, like if I simply do stack one dot pop, pop will actually remove the last element. So 4 is now removed. Simple. So how is it printed? Now, if I am writing stack.top, so as I mentioned you here, like the particular element that is on the top, that is 4. So if I just simply write it again, so what we will be getting? If I just close this and I just run, we will be simply getting here 4321. Now, what does this simply? People would say that we should have got stack 1, 2, 3, 4. But as I just wrote you here, the structure of the stack. So if we are using top function, so the topmost element in the stack is 4, and then the particular element is being removed as well. So how is it removed? Again, I'm saying last in, first out. So this 4 will get removed. So then which element becomes the top? This third will become the top. Then after getting printed, this will also get removed and so on. So this is the way how is actually does. And then you can actually swap it as well. So again, the time complexity for stack insertion is big O of n. For deletion, it's big O of. So if you want to swap the contents of the two stacks, so you can simply use the function swap, and you can use the sort function also to iterate the elements of the data structure. So simply, this is the case.
So stack.top will give you the top element. So as I told you that when you see the structure of the stack data structure, you will find the last element that you have pushed, that is you have inserted, will be at the top. So when you do the stack.top, then you will get the 4, and after that, this particular 4, when you will pop, then this particular 4 will get removed first.
So, we will be having, like, you got the to know about push and pop. And since it is a sequence container, sorry, it is a, like what? It is your container adapters. This is what? This is your container adapters. And as was the case for sequence containers, that is your vectors, arrays, and all. So for insertion and deletion of this particular data structure, your time complexity would be big O of 1. And if you go for sorting, like all the elements of a particular data structure should be in ascending order, because sort does what? It gives you the particular data structure, that is all the elements in it in sorting order. Now, what? So from this particular from this particular statement, what inference we can draw? That in a STL, in STL, the data structures, and in those data structures, the elements are stored in such fashion that the greatest element is at the top. Simple. Like this inference can be generated that the largest element in general, by default, the greatest element will be at the top. You can see like this. The greatest element is at the top. So this is the case. And just like that, moving on for sorting, you got to know sorting would be having the complexity as big O of log n and log n. Sorting complexity would be big O and log n. And for swapping and all, swapping size or size, whatever you take, it would be having time complexity as O big O of 1. So next data structure that we will be having is simply, I will change here only, will be Q. And from stack 1, I will be naming it to Q1, and push remains the same function in case of Q as well. This is like, but why it is giving an error? Since I haven't written the correct name of identification. So I have taken Q1, Q1. Now this is correct. For stack, I will be writing here as Q1. And stack dot top, for Q, you don't write top. you use the function front. In place of top, you use the function front, and for basically popping, it's just the data structure name. So I have changed this. If I just tell you one, so here will be only one. And then now you must be seeing that this particular structure is there. First is the type of data structure, then its data type, and then the data structure name. And finally, you inserted the elements, and then you check whether the particular queue is empty because you wanted to print the elements. And you are checking here that your particular queue is empty or not. And you are just getting each an element printed, and you are simply deleting it as well. Now, just like stack, I would like to tell you about queue as well. So for queue, we simply have like a queue, your queue, your queue simple follows FIFO data structure. Now, what is FIFO data structure? Suppose I have got like an element. So how is it inserted? Like FIFO means if an element has been inserted at the first place, then it will get removed first, like first in, first out. FIFO stands for first in, first out. Now, supposedly, firstly, I again inserted one, then two initially. Just understand this. So, in this case, if you just print each element, then you will find that the order for this particular structure would be like this. Let me tell you. For Q, the element, the element that will be deleted first is placed at the top. It's as simple as that. So, let me do this. Now, what I will be writing? The element that will be inserted first. So here, which element are we inserting first? That is one. So in order to delete one first, we will be placing one here, two here, three here, and four here. So when you will be popping this element out, the first element to get removed will be the first element that was inserted. So that follows the principle of FIFO. So if I just run this code, so you will find the output will be 1, 2, 3, 4. Unlike stack where the output was 4, 3, 2, 1. So you are finding the output here as 1, 2, 3, 4. And this got terminated because you are popping as well, and there will be a time coming where it will simply get empty. Now, again, since it's a container adapter, so for its insertion and deletion, your time complexity would be big O of n. For getting the size of the queue and swapping it, the time complexity would be big O of 1. And for sorting the contents, its time complexity would be like in queue, if you want to sort, then it is already in the ascending order. Like not here, it is in the ascending order. So there is no need. But if you put some random elements, so there is no principle to ascend it. So you have to sort it. So for that case, sorting queue, the time complexity would be big O of n log n. So I presume it's very simple. Now, oh, next here comes your priority queue. So now priority queue is what? It's another container adapter. So if I just erase it and let me write, because what is priority queue? I will first tell you. So priority queue is a queue where this type of queue, like in, let me tell you with queue, like you pushed elements in a certain order, and like you got it 1, 2, 3, 4. So here you find that the smallest element of actually the four elements that you push is at the top, but there is no guarantee. Like for an array, like if we just passes 10, 5, 7, 15. 10, 5, 7, 15. This is particular, like if we have passed it. So like 10 will be at the top, but actually 10 is neither the smallest element of the lot and it is not the biggest element of the lot. So priority queue is a queue in which actually when you will get it printed like this, you will find either the smallest element of the lot is at the top or the biggest. Now, generally, as I told you, for STL by default, the greatest element is at the top. So these particular priority queues are actually like C. They are actually like a heap structure, and in heap, the maximum element is at the top. Which element for priority queue? Like if I just place here, so I will be getting here the topmost element is suppose if I have written is like 50. So rest of the elements, like suppose I have pushed four elements and this is the first element. So rest of the remaining three elements will always be smaller than this. So this is the meaning and this is your like heap kind of thing. So I presume one element and one element like this. Suppose if I don't take it as four, I take it as simply five. So like this, you simply put I put it here like not four, but five. So in total, five elements are there. So the remaining four elements will always be less than 15. So that is priority queue. And what kind of structure they use? So to get the element pushed inside a priority queue, we normally use the your sequence containers and two of the very common sequence containers is your vectors and is your arrays. So like this. So these two form any of these two commonly form your internal structure internal structure of priority queue. So moving on to our VS Code. So if I'm going to write here like your priority queue. So priority queue, then simply I will be writing int and then I will be pressing PQ. Simple. So this is your header. Like this particular is your header of the priority queue structure. And then I will be doing what? I will be declaring here a vector. Since we are dealing here in STL completely, and so vector we have already done. So vector intg, and since we are studying here priority queue, so we won't be declaring this vector like that fashion push and pop. We will simply be doing like 1 5. No, I won't like do like this 5 3 1 and 10. This is your case 5 3 1 and 10. This is the particular vector. Now how we will be pushing it? That is the case. So simply what I will be doing here for vector, I will be declaring here the iterator. Now how we declared the iterator that time? We declared it like this. So it shouldn't be, it should be iterator and iterator should be I. Simple. And I we will be writing here like this, and we will be starting from v dot begin, and I will run till equal to v dot end, and I plus plus. Simple. And how we will be pushing the elements. So here is the function pq dot in place. Here push is not used. Here in place is used. And what we will be doing here? We will be simply doing like this. This is the method of in placing it. And if I write, so instead of push that we normally use to insert the element inside a data structure, in priority queue, we will be using the function in place. And what the comment, what should I write? This method of insertion, inserting an element inside a priority queue. So moving on. Now, since we have inserted the element, so we will simply do what? We will simply print it. So for auto I iterating on PQ, and we will simply be doing here C out. Simply, there is no need. We will simply do this. As simple as that. We will simply be doing this, and we will simply mark it space, and we will do like this. So, like we were doing here, what we were actually discussing about priority queue. So, how we will be doing about this? We will simply be writing while, and a very simple syntax. No, different. And we will simply, for priority queue, we simply use here. Now, here is the case, like you have to write here like this. You will be using your top that you do in stack. And as while you are printing, you will simply pop it out as well. So you don't need to print it. PQ dot pop, and just like this. This is your code. And if I just simply run it, so if I just simply run this code, you will find that which element will be there. So you will find 10 will be at the top. This is the priority queue. You will find the 10th element. So you find that 10, 5, 3, 1. So to make it more clear, I will be using here endl. So again, I'm running this code, and you will find that you will get 10, 5, just like that. The greatest element is at the top. So you got it 10, 5, 3, 1. So this is actually made on max heap thing, and this is actually built on, and the internal structure of this priority queue, that is how its elements are arranged. They are arranged in the form of a vector. And you found that the since we haven't put any conditions, so by default in STL, and that too if we are using priority queue, so the greatest element of the lot, that is the greatest element of inside a vector or an array, will be at the top of the priority queue. So this is all about priority queue, and then you can simply you got about removal of element, removal of removal of element. So hopefully this is clear. And similarly, you can go for as well of sorting as well. Sorting will again take you to the complexity of big O of n log n. Swapping and your size function will result you in the time complexity of O of 1. And insertion and deletion, the like in place and the pop process will result in the time complexity of O of 1. So since it's a container adapter. So now I will going to teach you about the DQ. So what is DQ? So DQ is just like a vector or an array, or it is just like a simple vector or an array. The difference where lies, I'm telling you. In DQ, where the difference lies. The difference in DQ lies is like that. DQ, since it comes into the sequence container, remember this, it doesn't come in container adapter, but it comes in sequence container. So it must be similar to vector and list, that you have got an idea. But it is quite similar to list. Actually, it is quite similar to the data structure list. Now, you must be thinking of reason. So the reason here is that it is similar because it has got pushback function, and it has got push front function, and same goes for popping. Like same goes for removal. It has got pop back function as well, and it has got as pop front function as well. So if I'm just going to write, so header will again remain the same, DQ. I will be writing here DQ, and I will be writing here INT. That is the data type of the structure, and then simply I will be mentioning here DQ. That is the header of the declaring the data structure. And then how we will be inserting. So inserting is again the same. We have got two functions, DQ dot simply push back, That will result in 12. Suppose if I've written, then I've written as, I hope then you have got the meaning of push back and push front. Push back again, I'm pushing 20, and now I will be pushing through push front. I will be pushing through push, I will be using your push front. I will be pushing the element through push front function, and I will be placing here 50. So now if I put like while not dq dot empty, here we have got the function. Now, if this is the feature of the VS Code, that if you are using it and if you have like written and declared the data types correctly, so you will get the functions already. Now I will be doing here cout. What I will be writing here dq dot. We have got the function here as at. If you will be using here top, there is no function like that. If you will be using here front, the function is here that. So if you use the function here front, so you use it, and I will be writing here endl. What I will be writing here as endl, and simply I will be then using now pop front. Either you want it pop front or you want it push front. That is the case here. That is the catch here. So I will be using here as dq dot pop back. So now if I just try to get you to the like what if I try to just get you now, you will be finding what will be the output. So initially, if you just take while how it will must have been placed in the stack. So I tell you how. Like you must have done here, you have got a data structure of a DQ. This is your data structure DQ. Now, initially you place 12, okay? Then you got here as 20, and then you used here as 50. So this particular data structure would have gone here like this. So output should be of that kind, and when you like do here as pop back, so how the output gone? Since you are following here as DQ, so you use pop back. So pop back will simply take your output in that kind. Now you got this structure, how this particular structure actually got it here. So I think you must be knowing about how this particular structure you got here. Firstly, you use 12, then you use push back. So you got the element below 12, that is 20, and then you use push front. So you will obviously be getting here at 50. This is the case. So this is your structure, and when you will be printing here, so the front element will be your 15 and like 15. So now you use pushback. So the next element that you will be getting here, you have to get it from the push front. Simple. If you are using your front, so just like I'm telling you, just firstly get to the output. You will find here the output. You got here as 15, 15, 15. The reason being is there you are using push pop back. So and that pop back will result into firstly 20 getting disappeared when you got printed 15, and then again 15 will be printed because the top element remains the same. So there is no again 12 will get disappeared. So finally again 15 will get printed, and then your stack becomes empty. Sorry, your queue becomes empty. Your DQ becomes empty. So how to avoid that? So in order to avoid that, we will be using here the function push back. We will be using here the function, sorry, not push back, but pop back. Simple. I will show you again. Now you will be getting the output as 15, 12, and 20. You got here the output again as 15, 15, 50. Now, why this is happening? So, I realized here that as I told you that DQ is a sequence container. What it is, that DQ is a sequence container. So, I can't actually get it printed like this. So, I have to use here an iterator. So how we will be going here about simple concept I'm telling you. We will simply be doing here as like we will be declaring here an iterator and then using the begin and the end function, we will simply get it. Now, when we are declaring iterator for that, so how do we declare iterator? Now, how did we declare iterator for another container that I told you initially? That was vector. We mentioned here dq, int, and then we used this, then we write here iterator, and this is your I, as simple as. So for int, not exactly int, but we will simply be using here as simple as that. I is equal to dq dot begin. So this was the mistake that I was making, and I is equal to dq dot end, and I plus plus. This is the case here, and we will simply be coming here and see out what we will be writing here. We will simply be writing here asterisk I, and that is it. If it will approach end, like if it will approach end, then it will go to the last address of the data structure I told you in case of the iterator. So we have to mention here like I. We will mention it like this, and then we will simply do like this. So now what we had done and what was the mistake that I was making. So we will discuss both. The mistake that I was making was that empty function and that kind of using while loop and like getting it printed is for your container adapters. And DQ is a particular data structure which falls into the category of sequence containers. So we have to declare an iterator here, another component of the STL library, and then using a for loop from begin address begin. Now, what is the difference between not equal to why we are not going to the end? It is as simple as that. The end will take you to address, the last occupied address that is in the memory of the data structure. But your last element is at the data structure minus one. That is end. End will take you end minus one. This is the case. And begin will actually, as usual, it will point out the first index of a data structure. So we will run it and we will get our answer. Actually, I got here printed. So I made a mistake here. It shouldn't come like this. So yeah, all good to go. We will run it again and you will get your answer. That is 15, 12 and 20, which I just explained to you. 15, 12 and 20. You got it, I believe. And again, since it's a sequence container, so your insertion and removal will get you the time complexity as your big O of n. And if you want to actually do an operation which will only take particular element, which will actually delete at a particular index. Suppose if you will just want to not remove each element, you just want to remove a particular element or at a particular index, then it will just do it in one time, single time. It's a single step iteration. It is actually not iteration, it's just an execution. It is one time execution, so its time complexity would be big O of one. If you want to insert at a particular index, that index is fixed, or if you want to that particular value to be inserted is fixed, or same goes for deletion, so your time complexity would be big O of one. So that was all about your sequence containers and your container adapters. Now we come to the last set of your containers, and that is actually the last portion of our STL tutorial here, and that is your associative containers. So associative containers contain your set, multi-set, map, and multi-map. Now, firstly, I tell you the difference between all the four categories, and they go in pairs. Like for set and multi-set, I will be telling you for set and multi-set. Now, The first difference, unlike the STL other data structures and your set, is that here elements are arranged in ascending order. What? Elements are arranged here in ascending order. And the very same thing is for multi-set as well. And in set, you can only store unique elements. What you can store? You can only store here unique elements. Here, you can store a number of elements with the same value. Like here, two can exist in a set, but here only one two can exist. And ascending order goes for ascending and unique. Rest of the things are same. And if I talk about your map and multi-map, so map is a data structure which takes two things. It matches your key to the value, and the same goes for multi-map. Now, how is the difference here? Like that. That particular thing was for set. Ascending order thing was for set. It is only for set and set and multi-set. The things which have set in, like set and multi-set, two data structures. But if you talk about here multi-map, I hope it is similar to multi-map. It is looking like that. So in multi-map, it has got, or in map, it has got two things. It has got key and it has got value. It has got what? It has got key value. Now it is commonly called, while it is always said, it is called a key value pair. So what is this pair? Pair will also be told to you. And here key value is there, and here is your key value just the same. Now, what is the basic difference between map and multi-map? Just listen carefully. In map, unique keys have like values which can be same. Unique keys. Keys will always be unique and values can be repetitive. Like if you take key in int data type and your value in string data type. So one can have the letter A, two can also have the letter A, but one can have A and one can have B. That is not possible in map. But in multi-map, one can have A, one can have A. It is very similar. Values can also be unique and keys can also be, sorry, values can also be similar and keys can also be similar. So that is the case. And for all the operations here in mapping, time complexity is your O of n. N is simply the number of elements in your map. Wherever till now the time complexity is O of n, it is simply the here there n represents the number of elements in that particular data structure. So this is for all the functions that we use here in map. Simple as that. So how we do in set? So firstly, how we declare this. So for any kind of data structure, the declaration remains the same. Set int s, or I take s1. S can also work. So this is as usual what I'm writing here as declaration for data structure. This is similar. This is what declaration for data structure. Now what we'll be doing here to insert the elements, we will be using here the function called as insert. So s dot we will be using here as insert. We will be inserting here as 1. And let me tell you the thing here to notice. S dot insert here as 2. S dot insert here 4. And again if I do add dot insert here 4. Let me not take this as 2. Let me take this as 10. Because I want to show you that set always inserts elements in ascending order. Now what I did here is simply that I have taken 2 times 4 and let me show you how exactly there is a difference in the output. So how do you do it? Like if I tell you here, now you will do here what? If you want to get it printed here, so I will do the printing here. of this particular data structure. So I will be using here auto. Now remember the type of method of printing here. Like there is one method for printing of sequence containers, one is method is for printing of container adapters. So now you have to get the method of printing of two type of more, that is your, like, it is similar to the ones that you have already done, but which one to do for this and that. Like for set and multi-set, there will be one method of printing, and for map and multi-map, there will be another method of printing. So it is just that. So for auto, I will be writing here, I will be using an I, and I will be operating on your data structure. As simple as that. So I will be using here a C out, and C out will be doing what, it will simply be printing here. And if I use here enter to make it look a little bit explanatory, more explanatory, I will say. So what here I will be getting here. So now you will see what exactly actually set, the way set stores the data structure. Simple. I will run the code, and you will find here it is stored in the method of 2, 4, and 10. So now you will make two observations. That firstly, it is stored in ascending order. The smallest element of the lot was at the top. And secondly, it never stored two fours. That is, it always stores unique elements. So that particular four was dropped. So here is the thing, like number of elements. Therefore, I say whenever your time complexity here the time complexity is not O of n. For each and every process of set, the time complexity is big O of log. Remember, big O of log n is the time complexity for any of the operations that you do on set. So like that, where n is actually the number of elements that are in the data structure, not the number of elements that you push. So remember this, the number of elements in the data structure. This is the case. Now, now you have seen that we have got three elements in our set, that is 2, 4, and 10. So if I do here, like you see, if I do simply here, that for every data structure we are studying insertion as well as deletion. So how do we do for this? How do we delete the element? So here are two functions, erase and erase with a particular argument. Suppose I say s dot erase. Let us see what does this do. This is simple. So erase takes what? You have to see. Erase takes a particular argument. Suppose I say s dot erase 4. The erase function actually takes a particular argument. This is the case here. Erase actually takes a particular argument. Let us see how. Now, for erase, your remember that for erase. Now, erase has got an argument. So its time complexity, you can't simply say that it's O of n or O of log n because it's an operation on the set. Actually, not. You have to find, you have to here, you have to notice that it has got a particular argument and it will only work on that particular argument. So it's for erase with an argument x is simply big O of 1. I will run it and you will find it. You found initially that three elements were there, and then you did the erase operation. Erase operation simply removed the number 4. Simple. Like removes 4 from the set. Now if I had done here clear function does what? Clear function simply does remove all the elements from the set. It will remove what? It will do remove all the elements from the set. You just find it again. We will be running this code, and you will find here that it clear. Now clear does what? I will be writing here. Removes all elements from the set, and s dot erase x removes X from the set if found is the condition that you always remember, that it removes X from the set if found. Now, I will also be writing here time complexity would be O of 1, and here your time complexity, like it will be simply O of 1 because it is clearing all the elements. It is not insertion. Remember that it is not insertion. It is not insertion. It is simply erasing all the elements, that is starting from one index and it is actually ending to the last index minus 1. It is ending to the index minus 1, as simple as that. This is your clear and this is your erase. This was the function. Again, I say the time complexity for clear is your big O of n, and the time complexity for erase x when you do where x is an argument, then if found, if this is a condition, your time complexity will be big O of 1. So this is all about set. Now, if you do multi-set, it's not a big task. If I write here as multi-set, so multi-set, if I'm writing here as I will be mentioning here as ms. So now ms does what? Oh, so, okay, let's not make it a big task. We will take it as only. Now everything remains the same. It will again take in ascending order, but what the change will be, you will be getting the output as 2, 4, 4, and 10. Multi-set can take one type of value, like one number repetitive times. So we will check it here. You got it here. Like, okay, it is from the, like we have done it two times. Like we have printed the same thing, but you got the concept here like 2, 4, 4, and 10 because our data structure was multi-set and everything remains the same. Every operation barring your clear and erase will have the time complexity. I'm writing that also here, that every operation performed on set, DS is your data structure, will have time complexity big O of log n. I hope it's clear. So this was all about R, like set and multi-set. Now, next comes your map and multi-map, the last type of data structure. But normally for the insertion of map and multi-map, we take the concept of something called as your commonly called as pair. Now, before moving to pair, there is one more thing that I would like to now. What I'm about to tell you here is that, like, for simply using it, for set, there is one more operation that I would like to tell you here is what. So, this there's a function called as in place. In place. Let me just simply do it, like clear it, and I will just simply tell you about that particular function. I'm telling you about that particular function here. So that particular function that you have in set is your in place, in place hint. Now what does this function do? This is an underscore, remember. So now what does this function do? Your in place hint function. This function actually takes two arguments. Two arguments, I would say, and I'm writing here as A, R, G, S. One is your value that I represent from the letter V, and the other is your possible index. Like you hint, you give it a hint. This is not, remember, this particular index that you give here is actually not the actual index of the place where you want this value to be inserted. This is actually a hint of the value. And if at that particular hint or that value plus one or minus one, remember this particular is a hint and around about plus one or minus one, plus one, usually plus one. I would say here usually plus one. And if that particular value actually you find that is not matching that particular index. Like if you mention here a particular hint, and as I'm saying, usually plus one or minus one you can take, but usually plus one. If that particular value doesn't matches this particular value, like this value is already not inserted over that particular index, then this value gets inserted over that. This function is that. Again, I'm saying in place hint on a set data structure operates with that sense that it takes two arguments. One is your value and the other is your index hint. Now, what does index hint means? That this is not the actual index where the value is supposed to be inserted. This is the index. Actually, with this index, it identifies the position. This is a hint with which it identifies the position, and if at that particular position, the value that is supposed to be inserted given in the in place hint argument is not present, like that value doesn't match because set can only take one value, unique value. So this value gets inserted, and usually hint plus one you normally find. This was your in place hint, and I will be using your Google Jamboard again. So yeah, I will be creating a new Jam file. So to explain you about pair. So pair is what? Like if I write here as pair and I mention here int. So now how the way you declare it. Again, the data structure to store the value here is pair. And inside you mentioned like pair will always take two arguments. It's normally we all know that. And then we mentioned the data structure name. So it is very simple. Now either we can write the pair like this, and the way in method to how to get it printed. So we will simply say see out. We'll be writing here p dot first, little bit of space between the two, and then we will be writing here as p dot second. Simple. So this is one method of writing pair. I hope it's clear. So this is the case. So pair int. This is one. This is the method of, I again mentioned in its comment, declaration of pair. And this is the method of assessing it, how to get it printed. This is the method. I will run it and you will find the output. It is one space, one. That was your pair. Now, how do you declare it otherwise? So the other method of declaring it is like simple, one comma one. This is the method of declaring another pair. So it is another method to declare pair, and you will find again the output will be one comma one. So you will find again the output is your one comma one, and the other method to there are three methods of the creating a pair. So the other method to create the pair is your p dot make pair. The other method to do the pair is your p dot make pair. Now the third method of making a pair is simply that we mention it and then we write here as make, and then we will be writing here as pair. And pair in which simply we'll mention it one comma one. That is the two arguments that it will take. And then I will be running the code again, and you will find it is the output is still the same. So like these, you got the output that is one comma one. So these are three methods of making a pair. Now, why I mentioned about pair? Because as you saw in priority queue, the internal structure of storing the particular data structure elements was a sequence container, that is your vector or array. So here in this context, when you write about map, your internal structure is normally about like pair. You like mention it. So now how we are going to make a map? here. We will just simply see. We will simply again write here int, int. I will simply mention m1 or m, as simple as that. I hope it's very simple. You mentioned the type of data structure that you are taking, that is map, and inside that you mentioned about the key data type, that what will the data type of the key will be. Because in map we normally deal with the key value pair. We deal with what we will be dealing with simply key value pair. So you mentioned about the data type of the key, you mentioned about the data type of the pair, and then you did what? You did simply wrote the map name, like data structure name. So again, this is the declaration of data structure. This is the declaration of the data structure, and then I will be doing here like simply I will be taking how to insert it. So in map, I will be going to again use the insert, and in insert I will be doing here as pair int comma int, and we won't be using another variable. So why to take a variable here? We will be simply writing here as 1 comma 1. Simple, like this. Simple. This is one method. The other method of inserting here, like not the other method, but to take multiple values here, we will be taking it as int. I won't be making a like a big map, so I'm just telling you the concept behind that. So we will simply be taking here as m dot insert again, and pair int comma int, and then your value will come, that will be 3 comma 3. So you will find here that like whatever it is there, whatever is the case, you will find here. Or suppose I take here as 10, not 0, but 10. So this is your common. You did simply, I just took the insertion. Like I use the insert operator to get the elements inside our data structure. And inside that, since we have to pass a key value pair. So what does that mean? That inside the insert function, I will be using a pair. I simply use a pair, simply like that. So if I just go on how to print it. So in this method, I told you about you have to just keep in mind about how to get all the data structures printed. So like that, how to get it done. So how to firstly I will be doing what? I will be getting an iterator here. So how did I get the iterator here? I will be simply be using here iterator, and iterator will be I. And if you want to use a while loop, or a kind of a loop which doesn't take a big condition, or a kind of a loop, like we know while loop runs for what? When the condition to us is known, not like a for loop, like a simple. So what we'll be doing here is that we'll simply be writing here as m dot begin. Now, why I initialized it with begin is simply that begin points out to the first index of a data structure. So I will be using here as while I not equal to the iterator not equal to map dot end, because that is the end points out to the last stored address of the data structure, simply. And how we'll be doing here as that see out. Now here remember key, I will be writing here as key, and then I will be doing here as iterator dot first. Then I will be doing here as what? I will be writing here as taking a little bit of space. Then I will be using here as again I will be typing value. Then I or just make it like this. And then I will be using what? I will be writing iterator dot second. and then I will be using here the end of it to change the line every time. Now this is an ideal way to print a map. Now just like map also always remember this map and set always store like unique elements. Like map stores unique elements, key can have always unique keys. Map will always have unique keys. Sorry, not keys, but map will always have unique keys. So if I just print this, you will find here like what will be. So, so you are finding this particular loop is running indefinite time. So why is it running? We will find. Oh, why did this happen? So what the mistake I did was that a very common basic mistake that we normally do. I never incremented the iterator. So every time it was just simply printing the first two elements. It was never terminating. So we won't do anything. We will simply like again run it and you will find this. You found that. Simple. Now, map and set. What did you identify from this? That map and set always store the elements in ascending order. Now, in map, that was easy to identify the ascending order. What inference that can you draw from the output of the data structure of this map? That ascending order depends on the keys. Ascending order depends on keys because in map identification takes place from your called as keys. So remember this thing. I'm just telling you here. Remember this thing in maps. Ascending order keys. So this you have to remember. This was that. And suppose if I use here like this was the case. And if I print here now the case. Now the two important functions that we normally use here in map. Let me do print this. M dot lower bound. Suppose I mention here the value 3. So these two functions you just remember and C out M dot upper bound. I will be mentioning about 3. So just like that. And so this is why showing an error. I'm telling you. The reason why is this showing an error will simply be like this. You have to get M dot lower bound 3, that is first, and M dot lower bound, where what you'll be writing here 3 dot second. So this is the method of printing. Remember this. And now what you happen after you mention about first, you can also mention about like to make it clear. You can mention about some space. Same thing goes for this here. I will be doing like here this and this. Then I will be mentioning here and dot upper bound. Upper bound will be 3. That is your first. Now take some space. Then and it won't come semicolon this time. This will be m dot upper bound 3 dot second. So this is the case. Now, why is it? Oh, this I made a mistake. Hopefully this is not solved. Okay, that's great. So I'm again going to run the code and you will find what is the case here. So lower bound 3 comma 3 and upper bound you got 10 comma 1. So what it happened like that? Let me tell you. Firstly, you got the map and you know about the inference that you can draw from the map is that simply map will arrange all the elements in the ascending order, but in reference to keys. Remember, in reference to the keys. And then lower bound function, whatever index you will put, like whatever key you will put in lower bound argument. Remember this, whatever in lower bound argument, whatever key you will put, it will return the key value pair of that. And for upper bound, whatever key you will put, it will return like the above one. It will always return the next higher element because they all are arranged in ascending order. So if you put one particular key, the next element that is placed in the map will simply be returned. Now, suppose if I would have done here, key is 10, the last key is 10. Suppose I did that. So what it will return? Then you have to see then what it will return. It will surely return that particular element itself because there is no higher element in place. So let's see what it takes. It simply returned simply. It simply returned 3 comma 0. Now, how did it return 3 comma 0? So this is actually a case of indefinite value here. You just simply remember this is an indefinite value that it is given. As simple as it is pointing out to an indefinite value. So always remember that upper bound for a function after which it's not placed anything. Upper bound for a key in a map, not a function. Upper bound for a key in a map, or for which it's the last element actually for which the key you are passing in an argument, it will always return some kind of a random result. So for the proper analysis, you should always place somewhere upper bound for which there is some next element present. This is the case. For which some next element is present. Remember, for which some next element is present. So now just comes, and as you remember, for map all the operations. I'm writing here also in the comments, like for map all the elements present, sorry, for map all the operations performed are have time complexity big O n, and where n is equal to the number of elements in the data structure. Remember, where n is equal to the number of elements in the data structure. As simple as that. Now, if I write here as multimap, multimap will always take, this is your multimap. As simple as that. Again, everything will remain the same. But if I mention here as 2, multimap will take. Let's see. Multimap 2. Multimap can have two same keys. Remember that multi-map can have two same keys and can have two same values as well. Map can have two same values but of different keys. Remember that. This is the same thing. You can sort the elements, you can interchange two contents of the map, and you can do the processes like that. And again, for multi-map also, all the operations performed will have the time complexity as big O of n. Now, the last thing I would like to tell you about something called as heap. Now I just mentioned about heap they in priority queue, and I said about that they are built on max priority queues on built on max heap structure, max heap structure that I mentioned. So what is this heap? Let me tell you about that. Something. So basically heap is actually a data structure. I will take some, not much, but yeah. So basically heap is a data structure here. I will be telling you about. The heap is a data structure here which actually takes something called as it is implemented. Like if I write it here, just is implemented here in a in a range. Like you have to remember this thing in your mind that heap is implemented in a range. And what does it do? It provides faster. Now, faster is always in reference to your complexity. Faster your insertion, your insertion and deletion, deletion. That what it provides faster approach. If you want to mention here, you can also mention about faster approach and so on. Faster approach in insertion and deletion. Now, there are few functions. Now, again, I would say heap data structure is built on some of the sequence containers. Remember this, that your heap data structure, your heap data structure is built on one of the sequence containers. Remember this, it is built on one of the sequence containers. So, if I just mention it about few of the functions that actually heap has. So firstly, I will be writing here a sequence container since it's the internal structure for the heap sort, or sorry, not heap structure, not heap sort, but actually it is for your heap demonstration. I hope it's clear. So I would be mentioning here, it's not heap sort, remember, it's not heap sort here. It's simply a heap structure. It's simply a heap structure. Remember that it's not heap sort. I would be mentioning here because 23, 45, 23, no, 23, not 30, and 50, 60. Simple. Now, what I will be doing here is that I will be simply using a function make heap, and I would be passing this particular vector. Now, how I did this? I did this because simply I had to make a heap structure, and heap structure has its internal composition coming from a sequence container. I will be doing here is that for auto I applied on V, and then I would be using it here C out, simple V, and then end L. So like that. Now, why is it showing error? Why is it giving you an error? You just have to find out. Like if I've compiled it and if you will find out. So this will seriously give you some error. So why did this happen? So before you go about doing this, you have to firstly do it here like this. You have to place an in v dot begin. It is begin, and you will run it till your v dot end like this. I hope it's clear. So this you will do, and then how you will get it printed? Simple. How will you get print it. So I won't be doing here much. I would be simply making here a iterator. What I will be making here, I will be simply making a iterator, not but iterator, and this will be I, and that I will be simply taking for I is equal to v dot begin I not equal to v dot end, because end will take you to the address, that last address that a data structure is occupying, and this will take you to this, and then simply see out asterisk I, and this will simply take you to ender. I hope it's clear. So I hope it's clear now. So, and remember this make heap has its time complexity O of n. Remember this. This is your the context. Because it's always max heap, so the maximum element, that is the greatest element of the internal structure of the a heap structure, that is a heap, and heap always takes a something called a sequence container for its internal structure. So for heap, the greatest element will always be there at the top. This is the case. Now there are some more elements like v. If I do v dot push back, because it's a vector and I put here 100, and then I do what? Then I do v dot push heap. So this won't work like this. So I have to use here push heap, and push heap I will use what? I will simply use 100. I will be pushing this, as simple as that. So so if you want to put this particular element, like if you want to put this particular element in your heap, then what you have to do? You have to again take v dot begin, comma v dot end. This is as simple as, and using this particular form, you will get it printed. Simple. Firstly, you got it printed, and then as usual, when you are making a heap, the greatest element. It doesn't matter about the rest of the elements in heap sort. And sorry, in heap. Remember, it's not sort. Remember, it's not sort. Remember this. It's not sort. It's just simply heap structure in C++ST. It's what? It is the heap structure that is given in the C++ standard template library. This is simply a structure. It's not any kind of sorting. Heap always does. It's the max heap that you do, and it always does what? It always places the greatest element, that is the maximum element of a particular data structure, that is the sequence container, because heap structure is basically a sequence container, the internal structure. So the 100 was the element that you pushed, and then you have some other functions as well, like complexity. Again, I'm writing here complexity for this particular function is big O of log n. Then there are a few more functions here. Pop heap. Pop heap does what? Pop heap does what? It pushes. Firstly, push heap does what? It pushes one of the elements to the last of the lot. And pop heap does simply what? It simply takes that particular element from that particular data structure. That is your heap, and that element is removed. So push heap does what? It actually places one element. It actually places what? It actually places one element to the last. It does what? It actually places one element to the last, and pop heap simply removes it. Pop heap also has its time complexity as big O of log n. Max heap is simply a function with time complexity big O of n, and is heap until also has its time complexity big O of n. Now, what these two function does? Max heap, sorry, it's not max heap, it's is heap. It checks whether the given range is heap or not, and it actually returns. It actually returns the max heap subrange, that out of a range, like that is out of a range. Suppose out of a range, if on applying is heap, you are not getting that it is actually a whole heap, like whole range can be converted into a heap structure, then is heap until function also says is heap until will simply give you out of that particular range, which for which that particular range is not a heap, like whole range can't be made into a heap structure. So is heap until will give you the max heap sub range out of that. Like for that particular range, that heap structure can be made. So I hope that it's clear. And this was all about your C++ STL, that is standard template library. And where does this STL plays a role? So STL is basically a template library which will provide you data structures along with its functions. And when you are doing your coding stuff for like duplicates and all and every kind of structure, so basically like you now get to know that what is set, what is multi-set, what is map, what is multi-map, which actually takes unique elements, which actually doesn't take, what is vector, what will be its time complexity when you put element from one data structure to a vector when you have taken and you have to finally return a vector. So what will be altogether its time complexity and what is the structure? And STL won't you don't have to like do here sorting and all for writing for loops for swapping and all and different kind of that stuff that are already given through predefined functions given here in the standard template library. So this is the role of STL, and hope it's clear. Thanks for watching, and do like, share, and subscribe. Thank you everyone for watching. Stay tuned for more content. Thanks everyone.